Howdy, my name is Subiksha Sankar, and today I'll be presenting my work this summer focusing on lung cancer research. So during my time at the lab, I primarily focused on two projects. One was developing a custom tissue microarray, and the second one was working with our lung cancer database model. So a little bit about my internship before I begin. This summer, I researched at UT Southwestern in Dallas, Texas, and my supervisor was Dr. Lynn Kai, who is an assistant professor at the Peter O'Donnell School of Public Health, the Children's Research Institute, and also a member of the Harold C. Simmons Cancer Center at UT Southwestern Medical Center. Our lab primarily focuses on bioinformatics, cancer metabolism, and lung neoplasm. So a little bit about lung cancer. Now, why is lung cancer research so important? Lung cancer is a disease where tumors in the cell, or is a disease where cells in the lungs grow uncontrollably, forming tumors. It's the #1 cause of cancer deaths worldwide. In fact, it kills approximately 1.8 million people each year, which is more than any other type of cancer. So understanding lung cancer is critical because better research could save millions of lives. So currently scientists use mice to study lung cancer, but the research data from different mouse studies is scattered everywhere and really difficult to compare. So for my first project, our lab created a comprehensive database called the Lung Cancer Autochthonous Model Gene Expression Database, commonly referred to as LCAM-GDB. So I have the publication on the left, and then we also have a website version of the model on the right, and both of them are hyperlinked. And what I've done specifically for my first project is ensuring that this database that organizes over 1,300 samples is organized easily and having tutorials in regards to it. So here I've included tutorials to guide new users on how to access the LCAM-GDB model, as well as a breakdown of the different types of data analysis that can be performed. So I'm gonna go ahead and try to play one of the videos right now.
Going over the data review for the study's subtab. So looking over at collection, we can see the current database, and we can also switch to review the data sets planned for future release. Going back to the current database, we can see the session, which has links to the data repository, the title, PMIDs, and platforms, which has links to the publication and profiling platforms respectively. If I wanted to go ahead and download this as a table, I could click download, which would then take me to an Excel sheet having the session, platform ID, title, and PubMed ID in one file. Going to plan for future release, I can see the study, total samples, lung samples, the small cell lung cancer samples, the non-small cell lung cancer samples, models, genes involved, treatment, group by condition, and PMIDs. So this will also have a similar format as everything will be labeled, and if I want to download it, I can go ahead and click download and see that too. The next tutorial will be on samples under data review.
So that was an example of how some of the YouTube tutorials were. And moving on to the second project.
Hi.
The second project focused on creating a custom tissue microarray, also known as TMA. A TMA is a paraffin block with many small samples of tissue arranged in a grid so that multiple samples can be tested at once. So to make a TMA, tissue cores are punched from donor blocks, arranged in a grid pattern, embedded in a paraffin, and then they're sliced in thin sections to make sure that they could be stained and analyzed using various laboratory techniques. However, standard TMAs do have some current limitations for our project. They can only hold a certain amount of samples per block, and tissue can get lost or damaged during the slicing process, and there can be consistency issues from sample to sample. So that's why we went ahead and created our own custom TMA design. Our custom molds can hold significantly more samples, we reduce the spacing between the tissue cores, and we use a harder paraffin wax for better stability. Our redesigned models increase the capture area by 33 to 40%, and we're getting cleaner, stronger tissue slices with far fewer defects. This simple, low-cost improvement makes our experiments more efficient and reliable. So overall, looking back at this experience, I've had the opportunity to grow both personally and professionally. On a personal note, I've developed my confidence just in my abilities to do research and lab techniques. I've become more curious about science and lung cancer. I've become patient when experiments inevitably fail and built resilience through the challenges. Professionally, I've gained technical expertise in the lab. I've improved my problem-solving skills, learned how to communicate complex scientific ideas, and discovered the importance of collaboration in research, and developed just a genuine capacity to learn because I've realized research is always about learning. And most importantly, researching lung cancer has taught me how to approach its diagnosis and treatment from a scientific perspective. As a aspiring medical practitioner, I think it's really important to understand the science behind it, and this research has given me the opportunity to do that. So acknowledgements, I really want to thank Dr. Leggett, Dr. Wingenbach, and Dr. Gastel for their support during the Science Influencer Program. And I also want to thank Dr. Kai and Reza for helping me during my time at UT Southwestern and guiding me through the project and giving me the opportunity to do research at UT Southwestern. And this research was supported by the NIH funding. And that is it. Thank you. Any questions?